Right, good morning everybody. Are we still in morning? Before we get stuck into this, has anybody heard of any sort of idea what TSN actually is, what it stands for? Anybody come across it? Yeah, there's a few gentlemen. Anybody else? Good, that's fantastic, so I can, you won't tell whether I'm bluffing it or not. What we're going to talk about today is TSN. So, but we're going to do it in a slightly different way, because normally what we do is we would look at what it is and then how we apply it. But we're going to turn it on its head and do it the other way around. What we're actually looking at is what would motivate us to use TSN, and then we're going to take a look at what it actually means. So, to those ends, some of the things that would motivate you to want to use time-sensitive networking are more around the thirst for knowledge, the hunger for knowledge. I'm a technical specialist. I work on a lot of large plants. I'm doing a lot of work late in battery plants. And one of the things that surprised me was the sheer volume of information that a battery plant and the manufacturing of a battery unit actually requires. I was quite taken back by it. And also this information is required pretty much in real time as they're actually assembling the batteries, primarily for things like sort of quality assurance, track and trace, and so on and so forth. But the key to it really is what most people will tend to use this information for, that they're generating these huge swathes of data, is for the influx of AI, for the influx of improving their processes and the way that things behave. So the key to it all is, the thing that's really driving the requirement for TSN is a couple of things. Convergence of networks, which we'll talk about in a short while, but also as well, that what do we do with all this data? How do we shift it around the networks? At the cornerstone of all of this is that we're also seeing, I think everybody would agree, is we accept the fact that 20 years ago we'd have bought a machine, we'd have put it on the factory floor, and I'd have been quite lucky if I actually got a signal that told me it was running or not. That's not acceptable in these days, and this is where we start looking at like OPC-UA, and also with things like TSN. One of the key components, the cornerstones of TSN, is to do with this thing called quality of service. So again, has anybody heard of QoS? Yeah, one? Maybe more? Right, I'm a bit of a specialist on this, but for all the wrong reasons. I will openly admit that I have a 13-year-old son who's addicted to gaming. Okay, so during the whole sort of COVID lockdown thing, I'm working downstairs trying to get on the Teams, my partner's working upstairs trying to get on the Teams, and my son is caning Netflix, Spotify, online gaming, and all of a sudden I'm finding that I can't actually get online, I can't even do a basic Teams call, and I realise what's happening is that he has sucked all the bandwidth. I live out in the sticks, so that the internet's not great anyway, but the point of it is, he is using all of the bandwidth. So what did I do? I went out and bought a router that supported QoS. I set the router up so that the MAC address on my PC and the MAC address on my partner's PC, they were given a certain amount of sort of bandwidth, okay? So what it meant was, he was complaining about lagging, all right? But I didn't care, but at least I could actually hold a conversation with somebody while I was doing my job. So the key part of it is this QoS. That's a sort of fairly rough explanation as to what it is. QoS is the cornerstone of the whole sort of TSN, the whole TSN approach, if you like. Now then, convergence. This is a really interesting one. When we talk about network convergence, everybody in the room has heard about the fact that we're now putting larger networks in with more capability, and what you're finding is that from the IT perspective, who takes ownership of it, and the sort of things that we're passing across this network are pushing down from the north, and we're coming from a different perspective. We're coming at the sort of control level, and we're sort of pushing up, and the two are meeting somewhere in the middle. As a result of that, what we're getting are these things, or developing these things called convergent networks. So really the best way to think about it is that the stuff that we want to deal with, I want to send a signal in real time from this machine to this machine, and I want it to arrive there with a reasonable amount of certainty. That's also going to be running alongside potentially other live data streams. So I might have, say for argument's sake, a 4K camera at the end of a production line. I might be monitoring something on a machine, and that's being streamed across the network as well. So what we're trying to do is basically have potentially multiple streams of real-time traffic running over a network that is also supporting other things as well. VoIP, for example, video conferencing, all of this sort of thing. And this is all running over one network that's using QoS, so multiple data streams all running across the same network. So these are the two things we need to consider: convergency on the networks, and also as well this huge amount of data that we need to somehow shovel across the network. Okay, you might have gathered by now I love analogies. And this roundabout that you can see in the picture, this roundabout is actually the roundabout near my house, the one that joins the A1 onto the A66. And recently the traffic lights had an issue with them. So they put them into a default mode. This default mode it was absolutely awful for everybody. So sometimes I'd arrive at the roundabout at 6 o'clock in the morning, I'd be through in 30 seconds. 3 or 4 o'clock in the afternoon could take me 35 minutes. The problem with it is that the roundabout has no capability for adapting to the traffic. It is what it is, and you just have to put up with it. So where we are right now, when we're comparing a traditional network using sort of TCP/IP information, this is what we're really talking about now. What we're talking about is the fact that the real time, the little sort of the yellow blocks represent, I would say, heavy goods vehicles. Not that I'm biased in any way. And the little red square, particularly the one in the top right-hand corner, that's me trying to join the roundabout. What we're interested in is we don't want these collisions, we don't want these problems. What we actually want is we want a smooth flow of traffic through the network. What TSN delivers in spades are the mechanisms out of the toolbox that will allow smooth transition around my roundabout or typically across a network. Okay, so these are sort of two quite simple analogies to get to grips with. How do we do it? It has some very clever technologies that are built in. One of them, I think one of the most important ones, a lot of people would argue increasing bandwidth is important. Okay, what you are going to find, and we'll talk about this in more detail later on, is that what TSN allows us to do, in effect, is connect devices where typically on PROFINET would be connected at 100 meg. It allows us to connect at speeds from 10 meg up over to 10 gig. Okay, so by increasing the bandwidth, then obviously we can get more data across the network. Brilliant. But that's not necessarily ideal in more circumstances, because increasing the power of the network, it's more energy hungry, and that sometimes can create another set of issues as well. What's more important, I think, is more to do with this thing that's down the bottom here, which is we've got preemption. Now, in simple terms, and this is why my analogy all breaks down, is my heavy goods vehicle that's blocking me and letting me gain access to the roundabout. If you imagine that's a big data packet, what preemption does is as it enters the queue, it goes, right, okay, this is a big data packet and I've got a lot of other stuff coming along behind it, which is small, high-speed stuff, real-time data that I need to deal with. This is just a big old TCP/IP packet. What preemption allows us to do is, in effect, chop up that packet and to allow me, the RT packet, the I/O data, which is moving quickly with a higher priority, it allows it to transit through the network. Okay, so it's quite a clever technology. And this is another thing that basically TSN, this is something that is delivered by the new toolbox package at TSN. Who does this affect? Pretty much everybody. What you will find is the TSN mechanism is not aimed specifically at this point at a particular industry. If it became farm, could be factory automation, they all have their own sort of unique nuances that we have to adapt to. But the whole point of TSN is that TSN at present, it doesn't sort of pick and choose which ones it's going to be good at. What it allows us to do is apply a sort of blanket approach, if you like. Now then, this is to put things into perspective, okay? I'm dealing with some systems now, and when I came into the industry 10 years ago, or maybe a little bit longer, when I came into the industry initially, we were dealing with small amounts of data, we didn't have any eye out in the field, we were hardwiring everything back to the panel. What I've seen is over the last sort of 30 years, a complete change of direction. We're seeing more and more Ethernet devices, IoT devices, AI. The industry's moving at a far, far quicker rate than it ever has. You start looking at a typical car plant, it's not unusual to see 50,000 Ethernet nodes in a car plant. That's not unusual. It's not unusual to see a network cell with thousands of I/O points. It's not unusual, or thousands of Ethernet connections. The interesting bit out of all of this, I think, are the two elements at the bottom. What we are starting to find, this gives you an indication of where this data is all coming from. We're starting to have more and more conversations about the use of AGVs. And what the AGVs are doing is they're not just following a piece of tape on the floor. There's a piece of software running in the background which is basically marshalling these AGVs. We're having some very real conversations about the fact that I want traffic management for my AGV. I want to know exactly where it is. I don't want to lay a piece of tape on the floor because that AGV might want to go to machine 10. On the other hand, it might want to go to the end of the factory. We're having bizarre conversations about, well, I've got to roller shut a door. What I don't want is 5 AGVs all arriving at that roller shutter door at the same time, because it's going to cause me problems. I need to get that material to the actual where it needs to be used. These are all things that we've never really given consideration to, and that requires real-time traffic information being sent up from the AGVs, a little bit like a sort of like an old TomTom, or a little bit like a sat-nav or Google Maps that we rely on now. So it's not a fixed route that it's going to use, and the route could change and become dynamic. Now you can imagine the sort of information that's going to develop. We're starting to have conversations about the use of 5G, about that opening up, and about using that for controlling things like AGVs. And this is where the whole thing, this is where we come back to the fact that TSN and the mechanisms it delivers are enablers for all of these things. We're not going to go through all these. This is really for your information rather than for anything else. The key things that I would say is that we've covered some off, like the link speeds, but we're going to talk a bit more about it in detail later on. Some of the thing I think is interesting, and again, it's slightly difficult from a PLC engineering perspective. I find this a little bit difficult to sort of wrap my head around because I'm used to creating a hardware configuration. I dump it down into the controller, all the network elements are all in there, it just does what it needs to do. Things are going to change with TSN. What you're going to find is TSN will deliver the ability for us to swap units out. So I might have, say, for example, a robot controller that I want to use in this particular instance, but not, and I want to move it somewhere else to do something with it. This modularization of the whole sort of factory floor, this is an area that TSN really will surpass. This is an area where it's going to deliver things we've never heard of. So we're going to talk about an embedded networking model that TSN will deliver as part of the new standard. So again, what it'll allow things to do is reconfigure on the fly in real time. So I won't have to go to the controller, fire up my laptop, put the new hardware configuration in with my networking components and then download it. It'll be dealt with at the point where I disconnect and reconnect something else. So it'll self-heal in effect. Right. There's a few people in the room know what TSN is. I'm going to flip it on its head again because I sort of like doing that sort of thing. This is what it is not. Okay? A lot of people have this idea that TSN is a new field bus system. It isn't. What TSN relies on is TSN, or PROFINET over TSN. It allows PROFINET to take advantage of an enhancement of layer 2. So anybody who can remember back to the sort of the school days and the whole sort of ISO-OSI model, and you talk about the data link layer, which sits at this sort of layer 2, and don't worry for those that can't remember back that far like myself, because we've got a nice little slide coming up later on. The whole point of it is the magic happens in this layer. So we'll take a look at that. But TSN is not designed to replace PROFINET. It complements it. And it's all to do with the way that the ISO-OS model is actually structured, which we will take a look at. The key point of it is PROFINET is a complete protocol suite that actually sits on top of Ethernet. TSN isn't. TSN is a toolbox, something that we take advantage of. TSN has no capability for diagnostics on devices. It has no capability for addressing or programming devices. That comes from the PROFINET side of things in the application layer. What it is a toolbox. What I particularly like about it is that because this standard is, the project is managed by the IEEE and the IEC, it means that all of a sudden you've got a great starting point for worldwide adoption. Okay, so this isn't something that's just something that wither on the vine. Also as well is that we've already talked about the fact that some of the things that TSN will deliver, and I know somebody's going to do a presentation later on about this, and I think one of the key enablers, and I think I was chatting to a gentleman over there from Klansman, I think one of the key things about it is that TSN, because of the way it's structured, you've got PROFINET over TSN, and you have OPC UA over TSN. And I think one of the really exciting things about the whole TSN bag, if you like, is the fact that from my perspective, I'm constantly having conversations with people about, right, I need to get data from this machine to this machine. I need to do it in real time. Okay, we're not mentioning safety at this point, just in real time. I need to transfer some data. And I need an open standard to do it. Well, we already have OPC UA as an open standard, which, to be honest, in 99% of applications now, when I'm talking about connectivity, even within the Siemens world on a third-party piece of equipment, OPC is right at the very, very top. That's the one that we always start with. What this will allow us to do when it's implemented is transfer data in real time using an open standard across what I would say is the level just above the controller, which traditionally we would now call the sort of OT layer, in real time. What's not to like?
And what's the difference between IRT and TSN?
We're going to talk about that later on. That's getting into the nuts and bolts of it. Because you're right, it's an important point about when you look at PROFINET RT isochronous real time, and then you look at the fact that TSN can actually bring synchronization, then it's you look at it and think, well, all right, where's the benefit? Traditionally, and this is where we are right now, when we're talking about TSN, is TSN has the capability, as we will see, or PROFINET over TSN, has the capability to work with sort of field level devices. But then when you start looking at isochronous real time, if that is delivering synchronism as well, then, you know, where does isochronous real time sit? But that's a topic for a separate discussion. Okay. Hopefully this is familiar to everybody. So on your left-hand side, this is the ISO OSI stack. And really what this is designed for, it was designed a considerable length of time ago for segmenting and standardizing on the way that data is handled, Ethernet data in particular. So when you work right at the bottom of the stack, you can see that we've got this physical layer. That's to do with, you know, how we would actually connect the devices. It describes the cabling types, the connectors, and so on and so forth. The interesting thing is, and this is a key component why, as it stands right now, with PROFINET over TSN, it's never going to replace TSN, replace PROFINET, is because PROFINET sits at the application layer at layer 7. The bit that we're dealing with, or the bit we're really interested in, is the enhancements that TSN brings to the data link layer down at the bottom here. The nice thing about it is, and this is where we're moving to, you'll notice at layer 1 it has this plus MAU. So what we're really talking about there is media access units. It's the way that we would connect to the equipment in first instance. And you'll notice this TSN IA profile. So really what we've got is where we were before, on the left-hand side, PROFINET sits at the top. It's quite happy to connect to the existing units that we have right now, but at 10 meg. Where we'll be in the future is that potentially we'll be able to go all the way from 10 meg all the way up to 10 gig. Okay? So a massive increase in the bandwidth of the product. The nice thing about all of this, what I like about it in particular, is that all the magic occurs in the data link layer. So what it means is I don't need to worry about my projects because, you know, nothing's going to be changed, because the only thing that's really happening is that the layer 7 is now communicating with, in effect, a new set of standards that occur at the data link layer. So in simple terms, that's what TSN actually is and where it sits. Okay, now when I wrote this, I was thinking like Partygate Boris Johnson, because it's the sort of answer I'd expect to get from him right now. You know, was it a party or was it just an afternoon drink? Who knows? So, will I need to buy new hardware? Okay. What's interesting about all of this is that TSN requires a hardware block which is a particular type of semiconductor. So, if you'd bought a piece of equipment maybe 10 years ago, it would have had an ASIC in there, an Intel chip. That wouldn't be TSN capable. What we are starting to find is that there's a lot of equipment coming through, and we'll show you a little slide in a second, is equipment is being readied. So what I would expect is going to happen, does seem to be happening, is when it comes to TSN, the standards are now pretty much all in place. People are manufacturing chips that are TSN compliant. They are incorporating those chips into a device. So you actually could have already bought a device which is TSN capable, you just didn't realize it. It didn't tell you in the manufacturer specification. I know there's quite a few products out in the marketplace now that say we are TSN compliant. On the flip side of that, what you will find is if you dig deep enough, you will find that there are components out there in the small print that will say, we changed the operating system, we've actually changed the hardware as well, and at a later date we'll upgrade the firmware to give you TSN capability. Hence the reason, will I need new hardware? Well, you might or you might not, depending upon when you bought it. What's really interesting about all of this is that when TSN was developed, a core requirement of TSN is that it would be compatible and would allow devices that were not TSN enabled to run in a network alongside the TSN standard, which we'll take a look at. The one thing I do like about the way that it's all been laid out is the fact there's a very clear, you start off here, it's very clearly defined about the way that we'd migrate a system or put a new system in. This is what I was talking about. This was taken from a manufacturer's website. We're all agnostic here, so it's taken from a manufacturer's website. And what you can see, although you won't be able to read the small print there, is it says, is it TSN enabled? Yes, asterisk, with firmware update. Okay, so it means the chipset is actually already inside of the device. And we're starting to see more and more of this as I tend to dig a little bit deeper with our equipment. Hopefully, this will make perfect sense. When we talk about conformance classes in PROFINET, for those that don't, I'll give you a little bit of a lesson. When we talk about conformance classes, really what we're saying is it's either A, B, or C. And a conformance class is really a simple shorthand way of telling you what functionality that PROFINET device is able to deliver. The new kid on the block is the one on the far right-hand side, which is in yellow, and that is conformance class D. The bit we're interested in the small print, is the TSN bit. So if a device is certified and it's a conformance class D device, it will be TSN compliant. That's the way that it works. When it comes to TSN, the key to it is the use of what we would term boundaries. So we're going to look at some architectures in a second. But the key thing with it is the way that we can guarantee, the terms that people use is you've got basically you've got a talker and a listener, and then we have a data stream between those two devices. So TSN is based on the concept of, I already know up front within my domain what all the devices are, I know what all the data streams are, and the network is going to allocate resources that will allow that information to travel across that network as described. Okay, that's the key to it all. What it also does is devices that sit outside of the domain, now PROFINET devices are slightly different, but devices that sit outside of that domain, we are going to restrict potentially how much influence they can have. So we're going to bandwidth limit them, and that will be determined by the type of device that it is. The PROFINET devices, if I've got an older Class B PROFINET device that's sat outside of the domain, it will still be allowed access to devices inside. It can use, say if I've got a nice shiny new controller, PROFINET IO controller, and outside of the domain I've got an older Profibusted PROFINET device, it will still be able to communicate with it because there is special discompensation allowed by TSN for PROFINET devices that sit outside the domain. So really what we're all about doing is we prescribe up front what sort of performance we want, and we make sure all the devices inside of there conform to that standard. Okay, excuse me. This is a typical PROFINET system. The important thing is the little key up in the top right-hand corner. So you'll notice that I've got a grey device and a slightly darker grey device. This is typically what you see out in the field right now. So the grey device could be, the little HMI could be a SCADA system. Lower down below the robot, that might be a printer that works with the robot. It's just bog standard TCP/IP stuff. It's nothing to worry about. And it's all coexisting on the same network with all the PROFINET stuff, which is where we are right now. The next step would be is we decide to make some modifications to the system. So what we're actually doing is, if you look at the little key in the top right-hand corner, we now have the original devices, which were B, and the new devices that we've brought in are actually both B and D compliant. So they'll quite happily work with both, they don't care. At this point, we're not using isocronous real time. I've had a failure device, I've gone to the manufacturer's now said, well, that device is obsolete, but we can sell you this one. And when you get it, and you plug it into the network, it goes, right, this is just a standard RT network, so you're type B, just get on with it. It doesn't care. It will work in either mode. The next step is, and you'll notice now there's a cable come in. So at this point here, that's not working. At this point here, along the bottom, we've introduced a new cable. Now the reason that we've done that is because I have a combination of B devices, which were there originally, B and D devices, which is fine, but now I want to implement PROFINET over TSN, and this is where the domain comes in. The key thing to this is that when you're taking a look at this layout, everything within the grey box is within the domain, okay? And those devices are all devices which are either B or D compliant. The devices that sit outside, the slightly darker grey boxes, They're the real-time devices, type B. You'll notice that the controller is in the top left-hand corner. So there's nothing to stop the controller communicating with the other devices that sit outside of the domain. It will all continue to work. Okay? The key thing is the fact that everything within the domain will be using PROFINET over TSN. So the nice thing about this is there's a very clear sort of augmented route to an existing system through to a fully blown system that looks like that, where all the devices inside of there are TSN compliant, okay? And all of them can sit within the domain outside of the SCADA system and the printer, obviously. So all the other devices are either B and D or D compliant. Interestingly, one of the things that has come up a few times, in a PROFINET network, although personally I would advise that you do it, you can potentially install an unmanaged switch inside of the network. I'm not a big fan. It tends to cause me a lot of problems. Something you can't do in a TSN compliant network is you can't do that. You cannot install an unmanaged switch, it just won't work. And likewise, what you'll realize as well when you look at the original, just going back one, in here, what you'll notice is that down at the bottom here, at the end of the TSN domain, where it goes into the sort of darker grey modules, you'll notice that had it been flipped over and the other way around, the reason we've had to put this linking cable in around these components in the middle is the fact that what you can't have is you can't have TSN compatible devices type CC conformance B and then another PROFINET device. It won't work that way. You have to push them to one end, which is the reason why that link cable's been put in. Okay, I won't dwell too much on this. We talked about it a little bit earlier on. One of the nice things about the way that TSN operates is the fact that from a PLC perspective, I'm always used to putting everything into the configuration file. Now what we'll be able to do is be able to make modifications on the fly, including networks that are running isochronous real time, so synchronization, and it will just adapt itself. So it means that I won't be having to interrupt the process by stopping a controller downloading it again. The nice thing about it is that really the network's taking care of everything. The network is aware of what the TSN requirements are. It's made aware. The bit that I have read about it, it's quite interesting because although there's not so much written about TSN and the network and switch side, it would appear that most of the network switches out of the box will do this for you automatically, which is quite interesting. We talked a little bit around this. What we talked about is this enabler, which is this profile that sits in the layers sort of 5, 6, and 7, and about the fact that not only PROFINET can do PROFINET over TSN, but also you can obviously use OPC UA over TSN. And something is quite interesting, it's a bit of a throwaway, AVB, when I had a look into it, it would, if anything, I suppose it's probably TSN's dirty secret, if it has one, is the fact that a lot of the standards that have been implemented inside of TSN have been derived from this AVB, which is apparently some audio and video standard from years back. So it's, again, just something new. Right, we've all decided we want to use this, which is fantastic. So, where do I sign up? Where do I start buying it and putting a network together? I would classify this as a future-orientated technology, if you like. So what that means is there's an awful lot of work that's already been done. You're already probably buying products that have these components, the necessary semiconductor technology already integrated into it anyway, which is great. But what you're going to find is the standards are not quite complete. So again, for those at the back that can't read it, there's a couple of sections of orange. The interesting part is that I believe that from PROFINET standard 2.4, that embraced TSN. So that bit's finished, done and dusted. What you have got though is there's still some work to be done on 60802, which is the new, if you like, the new standard that we're going to use at this layer 2 level, and also as well something to do with configuration enhancements as well. But looking at it, when I've looked through the working groups and everything else, it looks like a lot of this work is a long way on. This isn't something that's just suddenly started. It was started a number of years back. So it would appear to me that it is getting to the point where it's getting close to fruition. Right, I work for Siemens, so we sort of sit clearly in the middle of all of this. You've got the PROFINET organisation at the bottom, and you can see that their arrow has stopped out because, as I said, with 2.4, although there will continue to be developments, the base work's been done for TSN, so it's all ready to go. OEMs sit at the top part. I mean, obviously with Klansman in the room, from over here. But what we are really waiting for is, again, from the reading I've done, being honest about it, it looks like I would expect to see within the next couple of years, and this is just generally reading across the board, all the manufacturers, all the information's out there, we should expect to see some sort of momentum within the next 2 years. We would expect to see people starting to look at this, the early systems coming through. So it isn't something that's going to appear, it's not going to be a partner must mean you can buy like tomorrow. although there are certain components out there that only support TSN. It's something is a future technology. And being honest about it, with all the reading up I've done, I think the future is very bright for this particular, for TSN. Worldwide adoption, it looks very solid. So as a summary, what we're expecting out of all of this is you'll hear people talk about plug and play, plug and work, plug and produce. It's all the same thing. What it means is you grab your machine, you plug it in the network, and it sorts itself out. That's really what it's all about. What we're also going to see as well is this robustness. So when we start to link these networks and we see network convergence and everything's getting plugged together, we'll deliver this robustness that we need, is this certainty. We can all deal with latency. You're never going to get a network that has zero latency. What we can't cope with is massive amounts of jitter in a real-time system. Okay, provided it's repeatable, that's okay. Latency's fine, but we don't want variable jitter. That's what we're trying to avoid. It makes things difficult to work with. Key thing about it is that there's nothing for you to do right now. Because everything that you're doing right now will be transferred into TSN in the future. So it isn't like something that new that you have to learn. You won't have to recode, you won't have to do new PLC projects. And the nice thing about it is that these standards will coexist, which I really like. And so the more I read about it, the more I like it. What I've done for you is the little video that's directly off the PI website. It's worth having a look. It's actually, it's one of the guys, the guy on the right-hand side, from Siemens, I think. He's one of the product managers in Germany. And he actually does a very, very good job of explaining about a lot of these mechanisms. And he does it in a fairly sensible way. There's not a lot of sort of jargon involved, which is very, very good. And what I've also done as well is there's a nice link there if you just want to have a quick look. I don't suggest that you start reading through the standards, but if you're interested in working out particularly where we are in terms of the TSN profile, it's worth having a look in there because you can see that these things have been around for a while and they definitely start to get to a point where they've got working groups that are looking and going, right, are we happy with the end result now? That's the sort of point that it appears to get. Right, that's me.